and humans should interact. And the core guiding question that motivated us to work on this problem is how can we make interacting with technology as natural as interacting with other people? The goal is not to read your neural signals or thoughts for the sake of reading them, or anything remotely close to that, but it's really about making it more connected. And this question to us is more important than anything else we could work on because we spend like 10 hours a day with our devices. It's the most dominant interaction we have in our lives. And so the big thing for us is how do we take that and turn it into an experience that can be more present, more engaged, and more human? And so what we're building is something that's a non-invasive, wearable neural interface. And there's two really key parts of it. The first is that interface has to decode a natural user behavior, something that people are used to producing, but that also can change over time. And the second thing is that it has to have an intuitive way of product interaction. And so I'll dive more into what these mean in the next few slides. But coming out of that are a lot of scientific and technical engineering challenges. Right? And they're all about how you build towards this product. These are problems related to robustness, generalization, and working across different people. So the first of these is this notion of how do you reliably recognize a user's intent? And there's a lot of reasons why this is complex. And primarily it's because people do things in very, very different ways. Themselves, with different people, and over time, right? And so the first thing that we have to do when we think about this is as we build our models to decode, as Ankita was saying, we have lots and lots of data, we're collecting these data sets to be able to do this. What we really want to be able to do is capture that variation over all of the kinds of ways that people could produce a behavior. And that's important to be able to get it to actually work, right? That's one of the two core principles that I talked about when talking about designing the systems. The second is variation in your environment, right? People sweat, people walk, people run. All these kinds of things create different conditions under which you have to make a device work. And that's one of the critical differences when you go from working on this in an academic lab where you can show it's possible to solve a problem like this at scale, to having to deploy it in a product in industry, because it's got to work in all sorts of environments. And the final one is a system will make mistakes. Right? And you want to be able to figure out how to correct that when it makes a mistake. So I'll give an example of a good experience and a bad experience here. When you type on your phone, or you type on a keyboard, if you hit the wrong key, it showed you that you hit the wrong key and you could hit backspace and fix it. We know how to fix it. When you talk to Siri and you say the wrong thing, 90% of the time you don't know why it got it wrong. You don't know what you were supposed to say to it, and it really makes you feel stupid instead of making you feel empowered to use it. And so this becomes a really, really key part of productizing neural interfaces, right? It comes back to this question of not just can you solve the decoding problem accurately, but what's the end-to-end experience? The second part of it is how does it work across people? So when you're working in academic environments, proving out the underlying technology for these kinds of things, you have a pretty limited sample size of people who you can work with. In the real world, different kinds of people from all different kinds of demographics are going to be working with your devices. And so there's two parts of this. One is, what's the onboarding experience like? How do you get this to work out of the box as a users? And so half of the really key core technical problems that we work on at CRISPR are collecting data across a huge variety of individuals, characterizing the differences in that data, understanding what physiological sources they come from, and what motivates the actual structure of those differences, finding ways to normalize it, use it, and make it so that the devices can work quickly on. And then the second part of it is how do you teach a user to use this device? And how many of you read an instruction manual when you open up your AirPods or iPhone out of the box? Probably none of you, right? And so it has to be something where you put it on and you can learn what to do really immediately. Second part of this is how do you go from something that goes from a device that can work for novices to power users? A really simple analogy. When you start learning to type, you probably type with 2 fingers. Over time, you can learn to type with 5, but you can learn to type at like 150 words per minute. That's an example of a product that works for really simple interactions. Straight out of the box, you're like, oh, I want to type the letter F, well, so I'm going to take my finger and type the letter F. And eventually you're typing without thinking about the individual letters. And so just quick pitch for, we're continuing to hire across a wide variety of domains to make this work. It's an end-to-end problem, from machine learning science and software for the actual application platform, to neuroscience for understanding and decoding the signals, to industrial design for building a wearable that looks like something that you're going to be comfortable wearing into a bar, to mechanical and electrical for building out hardware, and to data collection. And so please feel free to reach out. I'm happy to answer any questions. Thank you. It's a great question. So to build something like this, you have to build completely end-to-end, from wearable hardware and industrial design, to decoding, to the actual software operating system that lives on top. Right? And so to your question, for example, let's take EEGs as an example. What kind of behaviors would that enable? So EEGs are, for those of you who don't know, sensors that can read electrophysiological signals from your head through your skull. And these are great for decoding high-level states that a person is in, or, for example, your response to seeing an image 300 milliseconds later. That's not actually a natural way that you or I interact with one another in terms of behaviors that it enables. So instead, we're looking to other types of sensing modalities like EMGs, electromyography, which reads intention from muscles and electrical signals that go to your body, as sources of information that could be both robust ways of interacting and natural ways of interacting. Yes?
Thanks so much for sharing. This might sound more like a market question, but I think it ties on to your product. There's a lot going on in neural interfaces and haptics. What would you say are two key differences that differentiate your product or ideas from what's going on out there?
So, on the neural interfaces side, I'd say the key and core difference is that we're building wearable consumer technology that's not based on sensing anything related to the brain. And so the reason for this is because we want to build good product interactions that are robust and reliable and that are natural to use. This kind of distinguishes us from Neuralink or paradromics that are doing invasive intracortical brain-computer interfaces, which are great for medical applications, and other places like Neurable. But in terms of the more broad, like, computing ecosystem of thinking about what should computing beyond the iPhone look like, almost everybody is working on this in the context of displays. Right? People are going from this towards AR glasses, or VR headsets, or even AR contacts. But even if we're interacting with those kinds of devices, we need a way to be able to naturally do that. You're not going to walk around typing in the air or speaking out loud to your AR devices. There's no way to take that to mass market with the current modes we have in interacting. And so that's the reason for this consumer focus, but not via something like EEG, as we were just discussing.
So we have time for more?
Go ahead.
I might have missed it, but are you guys at the stage where you have like a product, or you're solving a particular problem?
So we are solving a particular problem. That's the only way that we can make R&D progress rapidly. And internally, what we do is we have a very specific sequence of demos for 3 months out, 6 months out, and 1 year out that gears all of R&D towards getting to the point of a beta consumer device. But we don't have anything released to market right now.
Okay. So do you have an idea what that data is?
We do, and that's all under wraps right now. Right, thank you.
Thank you so much to Sahaj for such a thought-provoking talk. I, for one, am extremely interested in what your company is doing. And so on to our second speaker for the evening is Satyananda Kashyap, who is a staff scientist at IBM Research, specifically focusing in on AI. His research interests include medical imaging, machine learning, computer vision, and computational storage, with his work spanning from radiology, interventional, and knee imaging. His research has several patents and publications in peer-reviewed medical imaging and artificial intelligence journals. Kashyap's research specializes in healthcare products and commercial applications, enabling client engagement in bringing machine learning to their use cases and developing bio-inspired AI systems. He holds a bachelor from Manipal University, a master's from University of Rochester, and a PhD from the University of Iowa, all in electrical and computer engineering. Previously, he has worked as a postdoc at the University of Iowa before he joined IBM in May 2017. Please help me in welcoming Kashyap to the stage.
Can you guys hear me? Okay. Thank you for the very nice introduction. So today I'm going to talk about one application on, this was a collaboration with a medical device company called Terumo Microvention, and what we were trying to explore was, can we use AI to, for interventional devices and their placement? So that's kind of the brief overview. So very quickly, just a background on what we're working on. It's on what stroke is. So stroke is a rupture of cerebral aneurysm or brain aneurysm, and that's the underlying cause of hemorrhage, which is the bleeding in your brain, and which causes nearly 5% of all strokes. And one of the reasons is the abnormal focal dilation. What that means is that focal is like a small area which is abnormally, like too much pressure hitting the walls of the cerebral arteries, and that results from weakening of the artery walls and often appears at bifurcations such as these in the brain, and they are generally classified as wide neck bifurcation aneurysms. So that's the specific problem. And in the population, rates of about 1 to 5% of the population have this asymptomatically, which means that it generally exists, and when they go in for a doctor's visit, that's when they find it incidentally. They don't go in for that, but for something else, and they happen to catch them. Those are generally the cases on how these are found. And if it ruptures, then it can be fatal. And most of the success is in cases where it was found incidentally and there is a higher chance of treating it. So what are the treatment options currently in the literature? So until now, most recently, most of the wide neck aneurysms were treated with a combination of these embolization coils, and they were assisted by these stents and in this wide neck Y configuration to keep the coil mass in place. And the general idea of doing this is that you don't want more blood flowing into this aneurysm region because that there is a chance that it ruptures. So what the doctors are trying to do is close it off in a way so that you don't allow blood to go into these regions, and so eventually they clot, and then they form a seal so that the normal blood flow is restored in those arteries. So more recently, so flow diverters are like finely woven mesh stent-like implants, and they divert the flow from the aneurysm sac to induce what I was saying, like flow stagnation and eventually healing of the aneurysm. So the device that we were working with Terumo for this AI application was called the Woven Endobridge Embolization System device, and it's an intrasaccular braided flow diverter, which is different from the complicated, like the coil and the stent. And this was developed specifically for treating such wide neck aneurysms. They were FDA approved in 2019. So what does a successful intervention look like if you go into a clinic? This was a video. Let's see. Okay. So that was supposed to be an angio, but essentially, like in current clinical approach to sizing a web implant, you have the doctors, the neurointerventional radiologist, generally does a preoperative diagnosis biplane digital subtraction angiography. That's what is the imaging mechanism. And it looks something like this. And over here, I see that, I just realized you don't see my mouse pointer. I'm sorry about that. But essentially, that the bell shape on top is what is the aneurysm region there. This is here. Okay, this is better. And to appropriately size is very critical for optimal aneurysms, because if you make it too small, then you still allow blood to flow into it, and that's no good. And if you make it too big, then you're adding more pressure onto the side walls of already dilated artery, and that is again not good. So generally how the interventional neuroradiologist does it is they capture the height, the dome, and then the neck width. And based off of that, they have the simple formula of the height and the diameter on which particular stent device to choose from. And then a successful treatment is achieved when they achieve like complete occlusion of the blood flow into the aneurysm sac. And this is kind of how it should be when you again do the digital subtraction angiography. So in this collaboration with Microvention, the makers of the web device, we wanted to try and understand if we can improve the site selection of the web device for these aneurysms, and if we could use AI-related approaches, be it automated or semi-automated segmentation methods, to decrease the time of measurements, because in the clinical setting, it's very crucial that they need those sizing quickly and accurate. So that was one of the aims. And overall, the end goal is still to improve the treatment. So in this talk, I'm going to talk about the AI-based, like the automated or the semi-automated segmentation method that we did. So first step is to identify the slice that shows the largest aneurysm section. So then the second step, generally when you want to do an automated segmentation method, so the first is you identify the slice with the highest contrast in the digital subtraction angiography. Then you identify the aneurysm region in the slice, that's the blown up of the smaller image. And then you segment the aneurysm sac, and that's when the doctors start measuring all the key metrics like the height, the dome width, and the neck. So in terms of what exists in the literature for AI-related work, there is some work in medical imaging community in these areas. So there was one work in 2019 that explored particular VGG kind of architecture for pixel-wise classification for this particular task. So there was another work in 2020 which used another automated detection and segmentation of the aneurysms in a sequence of 2D images plus time. So in our approach, we chose to use the transfer deep learning approach, wherein the idea is that you have a natural image. So you must have heard of these large models that are well trained and all of those. So this is one such example wherein you take an image that's trained on natural images. The whole idea is that it's a very large data set of nearly 300 million images. And it was not done for anything related to medical, but it was to identify these image labels in like 18,000 categories. That's what this data set is. Now, because we don't have such a large data set, what we leverage from this is actually this trained encoder. And then we feed in our images, and then we use that also with another decoder-based architecture, which is used to produce this pixel map later on. Now, the question is, why does it work? So one intuition here is that what deep learning does is it's got these bunch of layers, and each of these layers start learning from these low-level features to the fine-grained, like the semantic information. So what we're trying to capture here is that our hypothesis is that any transfer learning approach, when it's trained this well, would learn the low-level features, which is like the edges of an image and all of those pretty well. And we want to use that to fine-tune it for our problem. So the question is, does it work? So a little more on the segmentation approach. So we used the transfer learned approach, and then we had another segmentation part which would give you the eventual pixel, the pixel map for this particular image. So some more about, a little more details on the experimental setup. So this was a retrospective study on the WebIT clinical trial this is what they had used, what Microvention had used for the FDA approval. We had 81 cases across 30 different US hospitals for which we had informed consent. And out of which we had 144 images with viable depictions of the aneurysm sac. And that was annotated by an expert neurointerventional radiologist, Dr. Liu. So we just broke it down into 115 trained and tested on the 29 slices. For the deep neural network, the inputs were 1024 by 1024 by 3 pixels, and just the batch size. So implemented it on an NVIDIA architecture, just standard optimizer and standard learning rate. So what we did was we optimized for the dice loss, which is basically pictorially what you're seeing is if the blue is the truth and the red is what the network predicts, you want this to have the maximum overlap so that your dice score, so higher is better, and it ranges from 0 to 1. So on training these average, like just 29 images, you get a dice of about 0.9, which is it's actually very good. But then that doesn't really paint the full picture, right? You just have a subset of 29, so you want to do more. So what we did was a K4 setup, wherein you take all of the 144 images, and then you cycle through the training and then test on the remaining. So on an average, you have about 134 images for training, and then about 10 images for testing. So we again did this in the cropped aneurysm. We used the same efficient NetB0 retrained architecture, and the average dice performance across the entire thing was like 0.9 with a standard deviation of just 0.062, which is really good, which means that the network can generalize enough across all the images on what a DSA image should look like. Remember, this was taken from natural images, so this is actually pretty good. Some selected comparisons to show you. So what you're seeing in each of these is that if you didn't have the pre-trained architecture I was mentioning, and you just had you trained it from scratch, that is like you didn't have the natural images go through anything. So that's when you get these kinds of results, which is like a dice of 0.7. The blue is the automated, that's the network, and the red is what Dr. Liu had done. So if you use the pre-trained architecture, you see that they do much better in each of these. And interestingly, I wanted to point out this particular case wherein you see this particular kind of kink on the neck, and then what Dr. Liu said was he had to go back and forth to kind of identify that there was another vessel in a transverse plane, and that's why he had to create this. And just feeding this one 2D architecture, even the deep learner managed to do it pretty well. Some more examples here of like good cases, but not everything is perfect. You still see some errors. On such a small data set, you expect these kinds of things. Now, the other thing was, like if you remember, we talked about like steps 1, 2, and 3. So wherein the step 1 was you get the full image, step 2 is you crop it, and then see if you can do it on those crop slices. What if you can do step 1 as well, wherein like you take the whole image and can you still identify? So it turns out that the whole thing was the same architecture. But the average dice performance did drop, which is expected because it's a much harder problem. There are a few cases where it fails completely, I'll show this. But one potential use case could be as a pre-screening for the aneurysm location on like a huge DSA stack. So in these cases, this is where it is, and then you see that the overlap is pretty good. This is another example wherein it does well. So this case is particularly hard because there was no contrast, or it wasn't subtracted, it was a raw angiogram, and it still did well. And then a few failure cases wherein like it kind of assumed that this region had something, and then there was a false positive. We don't know why this one was big, but that's another error. So these are some more numbers essentially. That's the baseline, the left column, and you got the average of like 0.6 over all of them. So if you had a pre-trained encoder so this is just the architecture without training on those natural images, you see a drop in performance, and then this is the one which performed the best that I showed you. And if you do the detection plus the segmentation, that drops as well. So overall, from these, like we just demonstrated that you can use a segmentation, like AI-based segmentation algorithm for aneurysm detection. But the next step, and it's pretty robust as well from whatever limited data set that we had. So the next steps are to explore like this for the actual measurements, like the area, height, and the width automatically, and then use that to actually stent the web device. That's what it is. And additionally, most of these angio studies with aneurysm have a rotational 3D C-arm angiography as well. So you've got stacks of these 3D data set, which you can also start exploring deep learning on. The advantage there is that you get the whole 3D volume as such, instead of these 2D slices. One of the issues is that the calibration and fidelity of size with the reconstruction is a challenge, so that's something we need to take care of. And there is heterogeneity in terms of like, the format and calibration. So yeah, thanks, and I'm happy to take questions. Yes.
Sorry, I got rid of the lost, or not sure we need the term architecture.
Okay. So when I say architecture, so if you have a AI system, generally they have these different layers of weights or what needs to optimize. So how you stack those weights is what you call as an architecture. So there are different configurations of it. And so we used, so what I showed you was there was the plain vanilla one, which didn't work too well, and then we used one which was optimized and it actually did a good job. Yes?
Yeah, so a question that I had is that what is the advantage of using a UNet for like medical applications such as this one?
So the first advantage is that you get the raw pixel map. That's one thing. And another reason is that when you have the well-trained features, what you call as the left side, the encoder, you also, the way the architecture is set up is you can share weights across, and then as it reconstructs, it learns from the original shape as well. So that's some of the advantages. But on a broader question, there's nothing stopping you from trying something else as well. But it's just that it works really well, and as a first pass, we just decided to go with that and seemed to do the job. Yes.
Did you ever consider any sort of bootstrapping or something that increases the amount of training on?
Yeah, so especially in this, because it was a clinical trial, we couldn't get data from Europe because of GDPR, but a simpler way is to just do augmentation or standard deep learning. We did use some of that, I forgot to mention those. Yeah, that's a good question.
Thank you so much.
Okay, thank you.
Thank you again. That was quite interesting, especially when we think of corporations such as IBM, we don't really think of the research side of things. We mostly think of products and stuff like that. So it's really cool to get that perspective from someone that works as a research scientist. So we're going to move on to our keynote address now, and this is someone we're really excited to have on campus. By all accounts, she is seen as a legend in the field, especially with AI ethics. So we'll do a little introduction real quick. Dina Omanoth is our keynote speaker. She is currently the executive director of the Global Deloitte AI Institute, and in the past she served as the CTO for AI at HP, among other Silicon Valley leaders such as British Telecom, Bank of America, E-Trade, and startups as well. She's also the founder of the nonprofit Humans for AI, which I'm actually a part of, that really emphasizes bringing AI literacy and diversity to underprivileged communities across the world. She also serves on the board of AnitaB.org, the Dean's Advisory Committee at Cal Poly University's College of Engineering, and she's been a board member and advisor to several technology startups. So please join me in welcoming Dina to the stage.
Thank you, Ali. How many of you have watched Jurassic Park? There are a few who haven't. Okay. So I'm going to make a lot of references to that movie, and I can tell you, what Sahaj and Kashyap shared, those were extremely interesting, fascinating topics. And I know I have to make my presentation a little bit more fun. because AI ethics is something that people just don't want to talk about, right? It's not as cool or fascinating, but it is something that I think we all have to think about proactively. So, is this helping? Okay. So today I'm going to talk a little bit about, do you remember that line from Jurassic Park? Just because you're scientists, they were so busy figuring out whether they could or not, that they didn't pause to think about if they should. You don't remember that line? That's one of my most famous, favorite lines from Jurassic Park. And for me, that's what trustworthy AI or AI ethics is. It's about the way technology can be misused or can go wrong, right? We focus as technologists, we focus so much on, building cool technologies because we think only about the positive things that can happen with technology, like the work Sahaj is doing with Whisper.ai, with the work that Kashyap is doing, right? But what happens if that technology falls in the wrong hands? Or even if it doesn't fall in the wrong hands, are there populations that are going to get left behind, right? Is it going to drive more inequality? Is it going to drive more inequity? We build social media platforms thinking that it's a way to connect with people, long lost relatives and families. But what if it starts causing more teen suicides? Is there a way to roll back? Is there a way to back out? So isn't it better to proactively think of the ways it could go wrong? Because we don't want to be those Jurassic Park scientists building that next wave of dinosaurs without really knowing what are the ways it could impact humanity. So today I'm going to give you a structure, a framework of how to think about ethics, right? No matter whether you're using a technology, whether you're applying a technology, or you're building the technology or the tool itself, what are some of the things that you should consider when you're in the ideation phase, when you're in the design phase, at every step of the way? So, like I said, I'm going to use some cartoons to keep you all engaged. The one that we hear a lot about in terms of AI and ethics is bias, right? We've all seen the headlines about AI is biased, we should not be using it. It leaves populations behind. And yes, it does, because it's based on training data, it's based on historical data, and it is going to cause bias. The question, though, when you are building a tool to ask is bias even relevant? A lot of what we see in the headlines is taking that approach of one size fits all, right? The part that Ani didn't include in my introduction because I didn't give it to him was, I'm a computer scientist by training, but my focus has been more on the application of the technology. So I've also gone ahead and done an MBA, and I've always looked at it from a business perspective, right? And having worked in so many different industries, I realized that it's not a one size fits all. There are AI use cases where bias doesn't even come into play, right? And when you hear those stories, you're thinking about every AI is biased, so we shouldn't be using it. So I'll give you two examples. One is, and this was a real use case that I worked on during my time at GE. Our team was trying to predict jet engine failure, so that we could proactively go and fix it and hence prevent unplanned downtime, right? Prevents flight delay. Very simple, right? Will be very useful. As we started, working through it, one thing we realized is in that scenario, in a pure IoT scenario, there is really bias is not a factor, right? It doesn't even matter, right? So it's not a true statement to say that bias is the most important thing in case of AI ethics for every AI scenario. But in that use case, what did evolve was we could actually see how the pilots were flying the plane. The impact there was, you could see if the pilots were following the training that they were provided. There were engines that failed more frequently because they were hitting thrust a bit harder, for example, right? So in that case, as you all know, AI, there's a big part of it is data discovery, right? You're trying to find those correlations, and you find correlations which you were not even looking for. we could now see the pilots who were not following the exact training guidelines, and the airlines wanted that information so that they could, it would impact their performance reviews and they could be punished and so on. And obviously, we didn't want to share that data because as a data science team, we were just focusing on trying to prevent jet engine failure. So the dimension that you want to think about in that case, the ways it could go wrong, this could now impact somebody's job, right? And you're finding information and there's no clear guidelines on what should be done. The other example I'll give you in the scenario of bias is, it's very important to think about the metric, the level of bias that's acceptable. Anybody who works in AI or machine learning knows that it is impossible to have completely unbiased algorithms, right? So what's the level that's acceptable? Everybody heard of facial recognition, right? Facial recognition, and what we hear in the media is when it's used in the law enforcement scenario to flag somebody as a criminal. If it is biased, it's a terrible thing, right? We do not want that out in the world. But that exact same technology is being used by nonprofits to identify kidnapping victims and human trafficking victims and rescue them in the exact same scenario, like literally at traffic lights, right? So in that case, the question to ask is it helping us rescue 30% more, 50% more kidnapping victims than if we didn't use it? And is that an acceptable metric, right? It's not a one size fits all, it's more of like, is this technology helping us in a way that level of bias is acceptable? So defining a level of bias, once you identify bias as a key dimension for your use case, I think the key is to define what's the acceptable level of bias. So this is another dimension to think about, right? We have moved in the software era, and I believe I might be the oldest person in this room. So I'll tell you, when I studied computer science, I started with COBOL and assembly language, and my first programming language ever was Pascal, which you probably never have heard of, but I think it's a beautiful programming language. But I've seen how this space evolved, and when we built the first, those first iteration, right? We didn't live in the era when software is deployed, and once it's in live, it's actually changing. The outcomes can change, right? Because your algorithm is learning and evolving over time. That was not the scenario, but now it does. So how do you ensure that no matter what data is thrown at it, it is still performing reliably? It is still robust enough to take those different data sets and continue to perform in a reliable way. Chatbots gone rogue, right? We've seen enough situations where companies have put out chatbots because they want to engage more with their customers, right? And then bad actors come in and train those chatbots to be racist and misogynist, right? And that happens, right? So the original intent was great, but if you don't put in those guardrails and think about it proactively and put it in, you have to pull down that chatbot. So, thinking about the reliability and robustness of this new paradigm of software and addressing it proactively is only going to help you. Transparent, this one, I'm sure you all know what that means, really being transparent. But in the world that I come from and having worked across so many different use cases, it really depends on what's the level of transparency. It's a fine balance between having to share too much of your IP, or you cannot really put out your competitive advantage over there. So what's the level of transparency that's needed? And in reality, all AI does not need to be transparent, right? If it's say a healthcare scenario, right? If it's AI that is used to drive patient diagnosis, I think transparency is super important because doctors need to know how is AI recommending a certain treatment, right? But if it is being used for, say, hospital bed management, how do you allocate hospital beds? Is transparency as important and crucial as for patient diagnosis? it depends, right? So I think, for each of these, I would say it's really at the use case level. It is important to think through these dimensions. It's important to see where does it prioritize in the application of AI in your use case. Are these cartoons helping? Is it making it a little bit more entertaining? Okay, cool. Secure, and this one is more, from a security perspective. And the nuance that I'll add is, we know about cybersecurity. We hear a lot about how AI can actually make our systems vulnerable. What I mean by that, my teams have implemented AI in manufacturing plants, in factory floors, where now machines that were very secure can now, you can attack those machines via, through AI. Or even the chatbot example, in a way, it's not secure enough if you've not put those guardrails, right? You've changed the behavior of the software. So you need to proactively think of what are the security vulnerabilities that you're opening by using AI. Explainable. This is another one very close to transparency. And for this one, I would say, again, don't think of it as one size fits all. The way you would explain what your AI solution does to a data science team or to an IT team will be very different than how you would explain it to your user versus how you would explain to your CEO and the C-suite versus how would you explain it to, incoming interns, right? So explainability again, it's not just putting out documentation for the sake of documentation. To build trust with your users, you need to be able to explain it in a way that makes sense to them. You've all probably heard of the scenario of, a self-driving car having to choose between hitting a pedestrian versus another car. You've heard all of the, those scenarios, right? And safety is, going beyond just the physical safety, the obvious ones, the headliney ones. And think about safety from a psychological perspective. Think about safety on mental health. How do you don't want to be the one putting out software or building applications. That's going to cause psychological harm. That's going to cause mental health crisis, right? We are living through that right now, and there is no way to get out of it, right? So as you start using these new technologies, using AI, it's very important to think about different aspects of safety and address it. I think we are all familiar with privacy, right? This is a dimension that Ashok mentioned as well, right? And we've seen a lot of movement from EU with GDPR. The key is the way we use user data. It's impossible to roll back, right? Consent is the users have to be very clear on all the ways that their data can be used, even if it is to train new models. What if they want to get, withdraw that data? It's impossible to do that once you've trained the model with using data, right? So I think you have to think about it from from a broader lens and AI. This one is a crucial one, and I can tell you in the corporate world, this is the one that always gets, feathers ruffled up. And the idea here is, no matter what project or use case that you're working on, proactively identifying who is accountable when things go wrong. Meaning, is it the data scientist who built it? Is it the IT manager who approved it? Is it the CEO? Basically, who is going to go and face the Senate or whoever it is when the AI goes rogue? The reason to do this and include it as part of your planning is it naturally raises that level of awareness and motivation to proactively think about it. So this one usually raises, and nobody really wants their name on the as the person accountable for it if things go wrong. So this is one that we've seen being very effective. And this one is a more philosophical one. I would say, thinking about that Jurassic Park line. Should we even be doing this? Is this the right thing to do for humanity? What if we discover later that we shouldn't have built it? Is there a way to go back? Now this one is a bit philosophical. It can be debated, especially for technologists. It is so cool to explore these new areas and build it and just let it out in the world, right? But you have to have that responsible mindset, be mindful before you go too deep, and you don't want to leave society in a worse place than where we are today. So I thought I'd end with a quiz, and then see if you have any questions. Do you think trustworthy AI and ethical AI are the same thing? Do you think they're different, or is it? For all those who think trustworthy AI and ethical AI are the same, if it's true, raise your hand. It's hard to say. Oh my God, I've got the smartest room here. Yes, it is not the same. So trustworthy AI, it's more broader than just bias or the ethical implications. It's being able to follow regulations, being robust, reliable, secure, bringing in some of those aspects. Solving for AI ethics is a data scientist's job. True or false? If you think it's true, raise your hand. It is everybody's job. It's the data scientist's job. It is it's the team lead's job. It's the CEO's job. Everybody has to think about the negative impacts of AI and address it. Every organization needs a chief AI ethics officer. False? True? True. No, not really. So here's the reason. If you are working in big tech, right? If you're using really advanced, trust me, I've worked in companies where they didn't even have digital records of data, right? Or manufacturing plants where there was no data being gathered. AI was so new, right? It didn't make sense to have an AI ethics officer. It was more feasible to start with following best practices. So if you are a big tech company, you're building all these cool technologies, you're very advanced in your AI journey, then yes, you probably should have somebody focusing on AI ethics. But if you are a 100-year-old company and are just very much early in your journey and using AI for expense report approval or whatever, simple things like that, you probably don't need yet. I think this follows along those lines. Hiring an ethicist will solve all your AI ethics problems. Yeah. Good. I think I already addressed this. This one doesn't make sense. Facial recognition should be banned until it's completely unbiased. It really depends, right? The only way, yes, false. Okay. There is massive investments going into AI, right? Into innovating with AI, all the new methodologies, but there is not as much investment going into regulation. I like to give the example, and this is way before my time as well, but think of the time when cars were invented, right? We had that time when the cars have just been invented, and all talk is about how horses are being replaced by cars, and what will horses do now? I'm kidding, but that's where the roads don't exist. The speed limits are not defined. There are no seat belts. We've just developed a car which helps us get from point A to point B faster than horses. So we are excited. That's where we are with AI, right? So we don't have all the lanes defined. We don't have the seat belts. That's why we don't have the regulations. the massive amount of investment that's going into developing the technology, there's not as much investment going into regulation. So regulations will never be able to keep up completely with all the advances that's happening in AI. So it is, if you want to be a trusted organization, you have to balance self-regulation and also follow regulations that exist. I think I addressed this one, right? AI will never be, do you agree that AI will never be completely fair? Is trustworthy AI a big tech issue? Is that only for the Googles and Facebooks and Twitters of the world, or is it relevant for companies like GE or Siemens? Do you think they should be thinking about ethics? It's actually the opposite. It's those companies, because they have been highly regulated. They've existed for a long time, right? So they think about the ethical risk much more than big tech companies. So because think about ethics, right? HIPAA exists. Now they're trying to think about what's the extension that needs to be done to it with the impact of AI, right? So it is an issue not just for big tech, but even companies that are just using AI, right? So everybody has to think. I think that's all I had. Thank you so much. Do you have any questions? Oh, I should write here. So. Yeah, there isn't. That was to my point, right? The laws will never be able to keep up because the pace of technology innovation is so fast. So it'll have to be a balance between self-regulation versus following the law. And it's also, it's not a one law fits all, right? There was a notion that there's going to be an AI law, but it'll be dependent on the use case. The laws need to happen at that application level. Yes.
Do you think that there should be a line from where AI starts to where do you think it should cross?
I don't think there will be a line. I think it's the next evolution of humanity. Look, I'm going to date myself here, right? But the jobs have always changed. They have always evolved. My bet is on humanity that we'll find that next. Like right now, the big talk is on generative AI, right? How many jobs it's going to displace, and especially for artists. I was recording a video the other day, and that whole crew was terrified because they're like, "Oh my God, our jobs won't exist in a few years. What should we be doing?" I think what we'll discover is new forms of art. I think we'll go through this iteration where the human-created art might actually be more expensive, right? There might be a whole category. So I don't think we can stop that. We can be mindful of how should we bring along the populations that is going to be displaced, right? I lived in I'm not that old, but there used to be gas attendants, for example, right? And the whole gas machines in gas stations got automated. That job got eliminated, right? So the jobs are going to keep changing. That's just a part of life, and we will keep evolving and getting better. I think there's a question here. Yes. There have been plenty. It is coming more and more in conversations even compared to 2 years ago, right? What happens is I think I'm one of the very few people who have a tech background and talks about ethics, it's mostly philosophy majors or marketing, right? So that's why there are these high-level headlines versus the actual solution. So companies are beginning to think more proactively about it, more in preparation for regulations, but also because the whole idea of ESG and purpose has come into play. So there are conversations, and I would say there are two scenarios. One is the companies that want to put have some ethical principles put in place so that they can innovate faster, like kind of lay the rails in place so that you can go fast. Versus a lot of them are like, oh, we have all these AI tools that we've acquired or built, and we don't know, but that we've not tested for bias. So we've seen both cases. Do I have time for anything or time? Okay. Thank you so much.
First of all, thank you, that was amazing. If you guys weren't able to ask questions, no worries at all. We have an audience panel coming up in a little bit, and then we also have a networking session at the end. So honestly, if I were you guys, I'd save your questions for the networking session, because you can just go up and ask Bina or any one of our speakers individually and create a connection there. So highly recommend that. In terms of schedule for the rest of the evening, we're gonna move into our panel right now. That should last about 40 minutes, and after that we're gonna move into our networking session. In between our panel or networking session, feel free to go outside and get some food. We have some pizza, chips, and water for you guys. So we'll let you guys know when that's ready. But right now, could I ask all of our speakers to come up onto the stage for our panel, please? And also, if you weren't here at the beginning, we do have a raffle going right now. We're going to pull up the QR code. If you fill the form out and submit a question, you'll automatically be entered into a raffle. 4 of our winners will be getting $25 Amazon gift cards, and our 5th winner is going to be getting a free signed copy of Bina's book. So definitely recommend filling that out right now. So 3 of our panelists right now you've already heard from and kind of heard their background. I'm just going to take a moment and introduce our other 2 amazing panelists that we have up here. We're going to start with Adina Simu, who is seated second from the right. Adina is the Chief Product and Commercial Officer and a founder of Auditoria.ai. A 20-plus year veteran of enterprise software applications and infrastructure, Adina has built software products using ML, AI, and fintech, legal tech, and cybersecurity. She held management roles at Oracle, VMware, Cisco Systems, and several startups as well. Adina holds an MBA from the Wharton School, a master's degree in computer science from IMT Atlantic, and a bachelor's degree in computer science from University Politecnica of Bucharest. Adina is CISSP certified and has been issued 5 US PTO patents. Please give it up for Adina. And our 5th and final panelist is UC Davis's very own Dr. Carrie Alexander. Prior to coming to UC Davis, Dr. Alexander spent more than 10 years in print and web design and consulting with many large organizations. There she encountered several ethical dilemmas in marketing to nationwide audiences, in many cases children and youth. She completed her PhD at UC Davis to research 1, how societies negotiate and govern business and consumer risk and relationships, especially in the context of mass audiences and evolving technologies, and 2, the roles, risks, and responsibilities for technology practitioners in a rapidly changing and high-stakes context. She is currently a postdoctoral researcher with the UC Davis Department of Agricultural and Resource Economics and the Socioeconomics and Ethics Cluster for the AI Institute for Next Generation Food Systems, led by UC Davis. In addition to her current role, she has also worked with the UC Davis Data Lab and served as a Mellon Public Scholar and Public Humanities Researcher for the state of California. She focuses on applied research and real-world problem-solving beyond academia. This perspective allows her to develop innovative and practical approaches to cultural, ethical, and socioeconomic challenges and strategies that co-evolve with emerging technologies such as AI. So please give it up for Dr. Alexander. So we're going to start off with some targeted questions for our 2 panelists that weren't speakers. Adina, I'd like to start with you. fintech is a hot topic that you tend to hear a lot about around college campuses, especially in econ and CS classes. As someone who is very involved in the startup space with fintech, could you please elaborate on what fintech means to you and what you see going on in the industry?
Fintech is a very, very large topic. It's technology for finance and financial services. I specifically focus on the technology that is built for the office of the CFO.
So I have a lot of experience with the technology that is built for the office of the CFO, Chief Financial Officer, and financial departments that are present in each and every organization. This is one area of fintech. Outside of this, there is fintech that addresses specifically financial services, banking, payments, and everything that supports the global economy. So there is a lot of stuff that's happening in fintech. About a month ago, I was at the conference in Vegas, Money 2020. This is the conference for financial services. The expo floor was the size of 5 football fields. Massive. So many companies, a lot of effervescence. There is a lot of change. There is a lot of excitement. Yes, for anyone who is looking to be associated, build products for fintech or work in this area, there is a lot of stuff to be done.
Awesome, thank you for that perspective. Again, if you guys are interested in learning a little more about fintech, definitely take the opportunity to ask Adina a question during our audience panel or come up to her during our networking session. Our next question is going to be for Dr. Alexander in particular. As I said earlier, you're heavily involved in an initiative for AI in food systems. Could you explain what that means and the interaction that you have with other universities in this research?
I'll try. I don't know if everyone knows what we mean by a food system or the food system, but it's everything from developing new seeds that might be more drought tolerant, agriculture, how they're grown, food packaging, processing, the food supply chain, consumer choices, and nutrition. So that is the whole spectrum of what the institute that I work for works on. As you can imagine, there's a lot of work that can be done in many different fields within that. And the exciting part about AI is that they're trying to use AI to find ways of growing more food with fewer resources. And you probably can imagine that is going to be very necessary. We will, in future years, need to be able to grow more food with less water, less land, fewer inputs. There's a lot of research, of course, about how different chemicals might be damaging to the environment. Precision agriculture, and in particular AI, can find ways of using things like microdoses of a chemical input instead of spraying an entire field in order to keep weeds at bay. Things like that. We also have teams working on how to identify food pathogens within the food system among workers in food packaging centers as well as in fields. There is just an enormous amount of work being done in this area, and it's a very exciting place to be. If you look up APHIS UC Davis, you'll easily be able to find the website and see all of the different projects that are being done there. In my work, I work in the socioeconomics and ethics cluster. So a lot of what I do is I look at barriers to the adoption of the technologies that our researchers are developing. And there are many, many types of barriers: cultural barriers, logistical and practical barriers, financial barriers. I interview all kinds of stakeholders, and I try to uncover what those barriers are so that we can account for them in the design and development of the tools we're creating.
So a question more generally applicable. How is AI actively transforming your field? And we'd love to hear from you. I can start. We build technology for the office of the CFO, as I was mentioning. How many of you are, let's say, associated with the Department of Accounting? UC Davis has a solid school over here. Programs, undergrad, masters, technology, artificial intelligence starts impacting how work is being done by folks who are graduating out of accounting departments. They start having tools that include AI, which until recent years might have been available only in other type of jobs related to sales or related to marketing. Not to mention, the tools available to folks that are building in engineering. I'll give you some very practical examples. So let's say that you're part of a finance team and it's your responsibility to make sure that customers of the company are paying for the products and the services that the company has been selling. What do you need to do? You need to produce invoices, send them to these customers. You need to make sure that they pay. And after they pay, you need to make sure that you understand what they paid you for. Right? So you can account very clearly, you can recognize the revenue, and you can use the money. So imagine that you do this with tens of thousands or hundreds of thousands of customers. And imagine that some of them are misplacing the invoices that you've sent over email. And they try to contact you and they say, hey, can you send me a copy of that invoice? Do you want to be the one who's looking up those invoices and sending them? No, right? It is something that AI can do. Do you want to be the one that actually starts looking at who has paid how much and is this already in the bank account? No, there is AI that can do that for you, right? Supporting you throughout your job so that you can actually get more time in the day to look at the much more interesting strategic aspects of the job, really participate and bring more value to your team and to the company.
I can go next. So I work across almost all industries and functions, and I'll just give a few insights. One is, we're seeing the AI transforming. Let's leave big tech aside, right? Companies that have come to fruition in the last 30 years, right? It's the ones that are before, from that generation, the legacy ones. The ones that have always been heavily data oriented, so financial sector, saying, and healthcare, those are the industries that's further ahead in their AI journey there, because they have data, right? And the companies that have been more heavy manufacturing or more in the energy or industrial space, those are the ones that are, not as ahead in their transformation journey as the ones with him.
I think on our end, there's kind of two parts. So one is how is it transforming neurotech? Two is how is it transforming user experience and interaction? And I already spent a lot of time in my talk talking about the latter, so I'll talk about what it's doing for neurotech as an industry. I think the big thing is that we can collect large data sets and do things with large data sets. And the reason why this is important is, until now, we've been able to do a lot of work in terms of just understanding the raw data at a scale where we can interpret and understand its physiology. The problem is, it's very hard to capture all the variation that occurs when people use systems with small data sets, because you just can't capture all of the ways somebody could do something. And so what you have is this ability to collect really, really rich data sets, really massive scale, and then do data science on them, because it's possible to actually process terabytes and terabytes of data across thousands of people and thousands of hours of interactions, and then use that to be able to train models that can interpret that data. And so it enables certain things across the board that weren't otherwise possible. And this is what's let you productize something, right? It has to work all the time in all environments, and that's something that is really only becoming possible right now.
I'll take a stab at this since I primarily talked about healthcare. So in terms of that field, even Ina was talking a lot about how it's far along, and I agree to that because machine learning as such, before the hype of AI or deep learning, has always existed in medical. People always try to find like algorithms, like old school regression and things like that to do something. What this wave has done with the hype is more and more people are getting interested, like traditional companies like for example the device company that we collaborated with, like Terumo, but they have interest and they see the value in terms of how they can automate things which you know, can actually benefit them. Now, I think one of the questions before was, or Tina mentioned, like, was like, I think the audience asked, like, can humans be replaced with AI? I'd say no way. That's I mean, the initial hype, there were some big AI researchers who said that's gonna happen, but I can tell you right away, like, we're nowhere close to that, and it's not gonna happen in the next decade or so. You know, it's like, it's better interactions and things like that, which, Whisper is working and things like that, which would actually help AI and humans move progress, but replacement, yeah, there's no way that's gonna happen. So I just wanted to give that perspective, so yeah.
Okay, well, I think I sort of already answered the question when I made the question, and I know we're short on time, so Libby, if you want to move to the next one.
Thank you. So this is definitely targeted towards Whisper, but anyone else who can speak to this based on their experience. AI is revolutionizing human-computer interaction. Could you speak on how you think HCI will change due to AI, especially in your product development?
Yeah, I mean, I think this is the topic of the entire talk, right, in a sense, but like, I think one of the things it enables is predictive interactions, right? It's beyond this notion of one directional, you provide input to a system, and it's bidirectional, the system provides input to you as part of the process of you providing input to it. And that's like a paradigm or just a way of interaction that hasn't really existed before when it comes to technology. But it does exist when people interact with other people, right? You communicate in so many different ways. Like when things aren't clear, people clarify things with one another, and you go back and forth, and you have this kind of dialogue, and you communicate with other types of interactions like body language and gestures. And so it's this really rich type of interaction. It's no longer like singularly kind of tactile, and you're always kind of guessing at what the other person's trying to say. You have this model of what they might be trying to explain, and everything that you're learning is how what they say deviates from that. And so, until now, right, interactions with technology have largely been interacting with a cold screen in some form, or some physical device. And both in just software or software hardware products, you're going to see this shift of predictive and interactive systems more than just you providing input to the machine.
I actually have a question over here, and would love to hear your thoughts because you're absolutely right. The interaction is changing. Is it that the input and output are disappearing, or is it that they become continue? Right? The machine is now so fast that it can actually analyze constantly what's coming in. It's really, really interesting. And you're absolutely right. It changes the paradigm of one communicates with a machine.
Yeah, when you close a loop between inputs and outputs, and then you make the loop really, really fast, you can no longer tell what part of the loop you're in some sense, right? It's very, very interactive.
I just want to add, I'm putting my Jurassic Park hat, so the question is, in what use cases is it applicable? Do we really want to improve that, that interface, make it so seamless that our teenagers are addicted to their devices and not going and playing sports or, doing normal childhood activities? Do we want to put it in the hands of our kids, right? What's going to impact it? But we also want to advance technology. Maybe it can help, the people with disabilities or senior citizens for the only, right? We're seeing that where it becomes seamless. challenge in front of us is that yes, we can advance these technologies, but we should also, make sure it's going to the right audience to truly advance humanity, right?
Maybe comment. I'll try to make it brief though. One example that comes to mind, there is a lot of work that should still be done in this area in the food system, and I can't comment on all of it, but one for example that I think shows that I think a use case can demonstrate both a solution and a problem. Using a robot in a field, for instance, to carry trays that workers might be depositing produce into that they've picked, right? It can be very useful, and it is possible to make it so that they're interactive and the worker can actually say when they want the robot to come and when they don't, and possibly send it away. So there's a lot of interactive a possibility for that sort of feedback from the worker themselves. But it also cuts both ways. The person can put their produce in and it weighs it and it checks the speed of how quickly they're picking. And when you're picking at a piece rate, it also has ethical implications for those workers. It will tend to pick up on which workers might be older or more tired or fatigued, which ones might be considered more productive, right? So it isn't that in one company you use a technology. I mean, that could also be true. You can have a use case in one company and a use case in another, and they're very separate. In one case it's good, maybe in one case it's maybe got some harmful implications. But in the work that I do, I constantly see overlap with every technology, every different case that I work with. It tends to have complications that go beyond just a simple, this is a great tool and it interacts with the worker. There's always going to be for the worker an implication that they have to be mindful of.
This question's for Adina and Sahaj, specifically. Due to this current climate, obviously you guys have started AI startups in one of the most competitive ecosystems in the world. How has that fared for you in terms of securing funding, securing talent, and what do you think your biggest obstacle has been?
Yeah, I'd say building a company in this climate is one of the best times to build a company. And it's because it forces you to really think about how to operate effectively and efficiently in focus. Because all of it is about how you can deliver on building a product as efficiently as possible, that's as useful as possible, and without wasting resources. And what this environment does is it forces you to take a step back and question every dollar you spend, but at the same time make sure that you use money effectively and solve those hard R&D problems. And so what we found in terms of fundraising and team building is that you can still raise capital in this kind of market. People know since 2008 and 2000 that some of the largest companies in the last 30 years have been built during market downturns, and so they're happy to put money into companies. And talent is, it's always hard to find really talented people, and it's something that we're constantly looking for. But people are excited to be building something new on a long time horizon, especially when we're in this kind of environment. And so in a lot of ways, I've actually been really grateful to see it and really want to take advantage of the mindset it creates. At the same time, I really hope it recovers soon.
So we have started in 2019. We have raised money in 2019, and we have raised money in 2021. And we grew as a company mostly during the pandemic, which has been a very interesting experience. We have been successful, but we got to build a team without really meeting each other face to face. And that was okay. Of course, we are lucky we build software. That helped a lot. We found customers during the pandemic. Guess what? A lot of customers, a lot of companies, they figured out that they need to use more software in order to do their business, right? told maybe 10 or 12 years ago that software will eat the world. That's definitely continuing. It's going to neuro interfaces as Sarah is building. It's going into all the areas that Dina mentioned, all the medical, every field that you know of starts using the new tools. Dina mentioned comparison with the cars. It's the same thing. They are tools. What you do with them, it's depending on what you're trying to solve as a problem and whether you know enough of that tool. And there are folks who know how to build cars, and there are folks who know how to use cars. It's gonna be the same. There are folks who know how to build AI, and folks who know how to use it, and the opportunities are endless. Communicating with the investors and all of that has moved online as well. Now we are meeting in person from time to time too, right? Because things have opened up, but nothing has stopped during this time. And I've been around as well for a while. These doctors happen on a regular basis. It's okay. We are gonna get through this. And then at some point there will be another one. It's okay. We are gonna get through that as well. As long as you're looking at solving problems that are not the problems of the past, and the problems of the present and the future, you're gonna be fine. You're gonna be fine.
So I know we have quite a few students that are interested in the startup space, and I think it's a good thing that we have resources for that stuff here at Davis, such as the Student Startup Center. So if you are interested in getting started with the startup, I would recommend asking these two, either now during our audience panel or during our networking session, and then checking out some of the resources we have on campus to see if you can get started. But yeah, with that, we're going to move on to our audience panel. We're going to have some of our Neurotech board members with mics. Just raise your hand if you'd like to ask a question, and they'll run to you, and you can ask whatever you like. You can either ask a directed question, just say who you're asking it for, or you can ask a general question, and you'll get a variety of responses. Any takers?
Okay, this works. So thank you panelists for being here. I have kind of a general question for everyone. So clearly AI has been infiltrating like a lot of industries due to the amount of data that's present across the board. Is there any particular industry that you think AI should not or cannot be a part of? And that could be due to multiple reasons. It could be ethically, like it has no place in it whatsoever, or is it a lack of data? There's simply not enough training data available, or situations are just too variable to really predictably train an accurate model.
I've thought about this, right? And I think industries that are high human touch, like massage therapist, acupuncturist. I'd asked this question to Andrew, and he said, barbers, right? They will never be replaced because you won't trust a robot with cutting your hair. Or who knows, maybe the next generation will, our generation won't. So, anything that involves high touch. I also think the ones that really need the human touch. There were a couple of startup founders who did this startup, and you might have heard of it, where and I'll share the idea was that doctors hate delivering bad news to patients or their families, right? Especially which is something that's critical. And so they developed an app where the app would communicate the bad news to the patient and the relatives, the families. And that is, I don't know, that's a terrible idea, right? It's worse than an app is delivering the bad news just because the doctors have trouble. So I think anything that needs a high human touch, where you need the human empathy or the human expertise, like a acupuncturist or anything like that, will be very tough to infiltrate in. It's the massive industries where those opportunities are there for automation, but not these high touch ones.
Another way to think of it is, this is an example from HR. I think everyone's aware of it, where they used an AI for screening.
Yeah.
That was a highly unethical one because because what is AI? In today's climate at least, it's what data you give in. So if you give garbage in, you get garbage out. And it turns out that it was already a highly biased data set based off of which it was trained. So many of these big tech companies use this AI-based screening for like applicants, and they saw consistent bias in that. So that is one area where you don't want AI, even touching those things, because at the end of the day, a human is always, probably more fair, or even if they're not, you can train them. Whether that's what HR does. So that's another example there. Another one probably are the intangibles. With today's models, you don't really catch those. Like one example is like when you do scouting, be it for football or whatever, they think that an AI predicts that he or she will be really good on the field, but then turns out that some rookie who no one even has heard of suddenly does very well. So that's still like the AI not able to capture those intangibles. So that's another area which I don't say AI shouldn't go there, just that today's models don't do well enough. That would be my answer.
Is there going to be another question? I'll just quickly add, I think that's where it's good to think of AI as one way of seeing, and not the only way of seeing. And so if there's a way that you can integrate AI alongside what humans do, then I think you can have that judgment, and you can have tact, and you can have sensitivity and intuition and all of those intangibles that were just mentioned. So I think that at least helps in terms of where it could be used.
Hey, so I have a very open-ended question for you that may or may not go anywhere, but we've been talking about ethics in AI and all of this and regulations. Obviously, our government is the source of many regulations within our life. Do you have any thoughts on how to get our politicians and those in government to understand how AI actually works, where it's applicable, and put in some sensible regulations that don't stifle growth? Because I look at all these problems, especially ones that, Bina brought up, and these are incredibly important to shaping the rest of our world, and I don't think that those in power have even a microscopic idea of what they're actually doing. Not to sound like I don't trust our politicians, but I don't know if you guys have any thoughts. What can a common person, or maybe I think most of us, a common tech person, do to help start this social change to understanding AI as more than just, ooh, this is going to, make the world different, but the fine-grained details?
So one of the particularly challenging things about this is codifying things in law often requires there to be a clean-cut answer to something. One example that I really like here is that there's certain definitions of fairness for a machine learning system that are mathematically incompatible, as in you can be fair by one and that will guarantee you that you are not fair by another. And so I know people who have worked at large tech companies working on definitions of fairness for different products, and because legal at one point promised that they would be able to deliver one definition of fairness, they could not move as a result of regulation to building something that they thought would actually be instrumentally fairer, because it would go back on that legal promise. And so, that obviously wasn't a constructive answer to the question that you asked. And so the constructive thing that I've thought would actually be really powerful is some notion of firms that can do fairness audits. Because it's remarkably complex and case by case. And it's not the kind of thing where you can apply a blanket rule and get an answer. However, if you have trained practitioners who can really dig in and understand for a specific company what they're doing and what kinds of consequential impacts it has, I don't know how that translates into a regulation, right? You can require that companies do something like this, but then there's all these perverse incentives around getting paid to do something like this as a firm. But it feels like there's something that could be done from that perspective.
Well, we just developed a framework for these exact reasons in our institute, and it's a different kind of framework than I've seen in a lot of places. But usually they do, there's like sort of a checklist or there are procedures, and it's appropriate to have some of those things. It's appropriate to have regulations to an extent, right? But it will never be able to know the code the way you might. You know, as a developer, you're going to know what you've made in a way that almost no one else will be able to know. I think one of my concerns is that the push for regulation seems to focus very much on the technology itself and on the way it's coded and the way it's designed, the algorithms themselves, and they forget about those legal agreements and those things that are happening in boardrooms and partnerships and contracts and agreements. And that's one of the areas that I've been heavily researching. In fact, I'm hoping, I've just written a piece about it, and I think I'll be submitting it in the next few weeks for publication. But that is one of the main concerns, and I think it's not going to be possible. Even if you did, you could probably have someone who is highly skilled do an audit, and I do think that that might happen, and I think there might be institutes, you might imagine it like the IRB, or any of you familiar with, if you do human subject research, okay, so it could go in that direction, where but one of the things we built into our framework were questions that you could answer and keep a log, so that you as a developer can document the decisions that you made. And that way, I would suggest we should put this in GitHub. We should put this, you make this part of your archive regarding the thing you developed, where you say, here are the decisions I made, here's why I made these decisions. And that way, as it gets handed off through the system and gets deployed in ways that you can't even imagine will happen, you'll always have that archive of what you intended for your technology to do. I think that is basically what we're working on in our institute. And I think it's important that we publish this and we start getting this in front of those ideas in front of policymakers and lawmakers. That's what I do. I'm trying to bring attention to that very problem, because they'll never be able to know enough. It's too nuanced, it's too specific, you use all sorts of discretion in making all of the decisions that you make when you're building a technology. So.
Quick add-on to what you said, there's this fantastic work from Google on what's called model cards for fairness that I've seen a lot of academics start adopting for certain things, where it goes through and talks about all the design decisions that you're making. It's really cool to look at as a template for certain aspects, and I'm really curious to see what version of it, or what different version you've developed for the kinds of work that you do.
Our framework isn't released yet, but yeah, we worked this year on developing it. So as soon as I have it, I can send it to some of the contacts here, and we can send it around.
All right. You guys have touched on this a lot indirectly, but I'd like for you to answer a little more directly. What factors do you think will contribute to future improvements in AI models and modeling, and how will this change their roles and how they're used?
So one thing is, I feel like as it progresses, there is more and more data, but then I feel like the hype is over. Like the pre-2010 hype is kind of over, and people are becoming more realistic. I think even like policy lawmakers, like the FDA, investors, everyone's becoming more realistic. So in terms of how models will progress, like you're seeing a lot of, if you see the news nowadays, it's more about like how AI is able to generate, like from say a bunch of 2D images, something 3D, photorealistic. So those are one direction of improvements. But then people are asking the tougher questions as well, as to like, so like trusted AI, embodied AI, or like Another thing is like, how do you democratize AI? That's another direction people are thinking of, because right now all those models that you see can only be done if you've got server farms and like you've got like 2 months to like run those things, or even 2 months is an understatement, I guess, but that's how big those things are. And the third direction is like, it's still a black box in the sense that all of these code things are so complex and nuanced that you don't know exactly how to break it down. Like, if you go back about 10, 15 years to classical machine learning techniques, you kind of understood the math behind it. In this case, you kind of are letting the networks or those algorithms learn, and like, it's very hard to break those down. So those are some of the directions, like, you know, where progress needs to be made, and I think there will be a lot of progress there as well.
One quick thing that I can add there, I know a lot of leading researchers in machine learning right now are talking about how we're to some degree stuck in a local optima of deep learning, and so there's a big push and trend towards thinking about neuro-inspired machine learning approaches, and a lot of this is exploratory, a lot of this may not lead anywhere, and some of these ideas may lead to just completely new approaches, or ways that you can get sample efficiency, or different things that change what machine learning systems look like today.
Thank you. So my question is mostly focused towards the women speakers we have here today. So in a field that's mostly dominated by men, I was just wondering, how have you paved your way to be where you are today? And what advice do you have for young women who want to pursue a career in AI?
The easiest one, by being really, really good at what you do.
I have to agree, there is no secret.
Sorry, I couldn't see which person is speaking, so I want to look at least in your direction. Answer the question. Well, I will just say I have worked really hard, and I came in through a very unusual path, and I've just continued to reach out and put myself in positions, working with everyone I could find who could help me along this path. And so that meant doing all sorts of very unusual things that my department here for my PhD didn't completely understand. Sometimes they didn't support it, not really. They weren't necessarily against it, they just felt confused. Like, why do you want to learn art? Why do you want to code? Why do you want to do these things? They didn't understand what I was doing, but you just have to know that that's what you want and just keep watching for those opportunities. And then I've found excellent mentors. One of my favorite mentors, I don't know if you want me to name her, but she's in the Department of Science and Technology Studies, and she was exactly who I needed to help me, make my dissertation what I needed it to be, so that I could actually end up doing what I'm doing now. So I think that was part of, I wouldn't say it's a secret, but that's maybe part of my job.
Hi, just wanted to ask about the ethical and trustworthy AI. So I just want to know which aspect of ethical and trustworthy AI would we look forward more in the future? Like, is there like which garners more attention relatively amongst all the different perspectives? So I want to know more about that, more particularly more in the future. Thank you.
I think right now, bias is garnering all the attention because it's so easy to understand for everybody. You don't even need to be able to understand anything about AI, but bias is just so catchable. I think in the future, it will be when AI intersects with other technologies, right? Looking at what are the ethical implications of the metaverse, of NFT, of AR, VR. We are not even talking about equity or equality in the age of metaverse or 6G, right? So when AI starts blending with other technologies, it's going to raise a whole new level of ethical concerns. And I think that's where the big gap is, and that's where we are heading. I think the current set, I think we'll get to those solutions, because everybody's aware of it. Researchers are thinking about it. The ones who are using AI are proactively thinking about it. It's the next iteration of new emerging technologies.
All right, thank you.
We got time for about 2 more questions, and then we'll go into our networking session. You can ask them one-on-one.
Hi, so this is a question more specifically about machine learning, but I've heard of some recent developments in models that can explain their process of how they reach certain decisions. I'm wondering if you guys think that there's a future in that, and that models will in the future be able to explain their thinking in a way that can then be used to improve the ethical implications and also just generally the trustworthiness of our artificial intelligence.
I do have a perspective on this. I've been using machine learning for a very long time in many areas. I've heard many times that one cannot explain how a model reached a conclusion. So guess what? Would you use a tool if you don't understand what it does? No, the answer is no. So if we are not able to explain, if the person who's using the tool cannot understand what it does, and the thing cannot be explained, it has no future. I do understand that it's harder and harder for a person to wrap their head around how the math works in these advanced models. But for some people, for the people who came up with that, it's possible. There is more advanced math, so get comfortable with more advanced math, all of us. We do need to understand what the machine does, otherwise we are not going to use these tools.
Just want to add that I think what you're trying to ask is, I guess you're referring to the black box nature of machine learning and how many key fields are not ready to trust it, or like some of the results there. So to answer your question, that's a very active research topic, and explainability is one of those problems which will definitely have to be solved for AI to progress. So that would be my answer.
My quick cynical take here is that they're all like anthropomorphized explanations, in the sense of it's not actually the reasoning the model was doing. It's something that's satisfying to a human to interpret as an explanation. And so we might understand the mathematical building blocks underlying it, and then we project something on top of it as saying, this is what it's doing, right? Chain of thought reasoning with large language model. Like, that's not actually the chain of thought that they're doing. The fact that we use something like chain of thought reasoning as a term to describe it is itself really anthropomorphic.
Well, I will just add that we should probably remember that humans are sort of the original black box. And one of the things that I think makes AI so fascinating is that it's possible that we may be able to understand AI more easily than we can human beings. And there's research on that, so I can send it if you want to know.
We have time for one quick one.
So, as a business, how do you decide you need an AI solution for a problem? Like, as a business, like, where do I bring in like an AI solution for a problem I'm facing?
You don't start with what technology you use. You start with what's the business problem that you're trying to solve. And AI could be one of the solutions. It could be some other technology, or it couldn't. There is no technology to solve for it, right? And the question is valid. The question I hear most often from leaders is, I have all this data. I want to use AI. What should I do, right? And like, whoa, what's your business problem? What keeps you up at night? Let's start with that, and then go to the technology, which is just a tool, right? So, and then how do you identify that AI is a solution? It's really by looking at your ecosystem of peers, competitors, best practices, the research that's happening in academia. Has somebody solved this problem that I can bring back to the organization? Or you hire consultants who do that.
True. So you're looking at the business problem, and then maybe you solve it with a Monte Cristo simulation. Maybe you solve it with something related to game theory. Maybe you solve it by collecting more data and having someone actually look at the facts. Or maybe there is something that is currently classified as part of artificial intelligence that solves it. Because by the way, there are things that were classified as AI many generations before, in terms of AI, which are no longer AI these days, right? So this progresses.
Okay, so that wraps up our panel. We're going to wrap up real quick, and then we'll move into networking. But before we wrap up, we do want to announce our raffle winners. So the way this is going to work, our first 4 people are going to be the gift card winners, and then the 5th person is going to be a signed copy of Trustworthy AI. So we'll announce it here, and then when the networking session starts, just come up and we'll get you what you want. So our first gift card winner is, sorry if I butcher this, Mutangi? You in here? Okay, awesome. Congratulations.
Our second winner would be Zainab Rizvi. And all of you can get your prizes like after if you want to come up during.
Our third winner is Arnav Rostagi.
Our fourth winner is Kiyomi.
And then Kent, you get a signed copy of Venus Book. So, yeah, before you guys come up and get your prizes, first of all, thank you guys, everyone, for coming. This is the first time we've done something like this at Davis, and yeah, we're just really excited to see the turnout. There's a new club on campus called the AI Student Collective that I'm going to be leading with Luke up here. Luke, you want to raise your hand? So if you're interested in AI and events like these that are really geared towards professional development at the undergraduate level, definitely come talk to us during our networking session. We're going to be working hand in hand with Humans for AI, which is Vina's nonprofit, and we're going to be doing a lot of national level initiatives such as inner city education stuff and just building an undergraduate network of AI students. So definitely come up to us if you're interested.
And leading on that, this is, first of all, kicking off the year for Neurotech. We have so much more planned, and I would really like to personally thank every single one of our panelists and speakers for taking the time to come here today. It's definitely a hike up all the way to Davis from the Bay, I know, but we really appreciate it, and we really appreciate you bringing your such thoughtful discourse to our campus, and we can't thank you enough for that. This is going to be but as he was saying, keep a lookout for other events also going to be hosted by Neurotech at Davis. We are opening up our applications for our division, so definitely come check that out. And yeah, thank you so much for coming again. We really hope to see you soon at our other events. And we want to thank you specifically to the Center of Neuroengineering and the ARC for funding us and setting all of this up for us and just making the whole process very smooth and easy for us to host these kinds of events. And thank you to our Neurotech board for making this possible. They're running around all backstage and behind the scenes getting us food and whatnot. So I really appreciate all the support there. And now we can start our networking session, so you guys can come up to our panelists directly and talk to them about any specific personal questions that you have or get their insights on anything that you would like. And the winners definitely come up to us and we'll give you your prizes. Other than that, thank you so much again for being here, and we really, really enjoyed hosting this event for everybody.
There's also food outside, so go crazy with that. Thank you guys. Have a good night.